Hello everyone. So today we are going to work on this hexagonal world. So that means here, if I go closer, this world is created with these hexagons. So this randomly generated world with blue part is water, and then a beach, then grass ground, then snow tops and rocks you can see in black color. So here, if I select the world generator and press this generate grid, it will randomize the world here. So still it's using these hexagons. So here you have parameters to change the scale of mountains, height of mountains, and the size of these individual hexagons. A lot of parameters are here for you to play with. So this is actually based on the voxel world that we created yesterday. So here we are going to modify the same voxel world generator system to use hexagons instead of cubes. For example, here if I increase the water level, let's say 20, and generate, now you see it's more like small islands, beach, and then only rock. So if I increase the rock level to 25, let's say, now you see the rock, there is a green level as well. So if I increase it further, the rock starting level will go further up. So yeah, this is what we are going to work on today. And before we get started, I'd like to remind you that you can download any project files of any video that I have covered in my channel in the Patreon page. So to the date, there are over 1700 videos. For each video you can download the project files once you become a member. So I'll leave the link in description below. Feel free to check it out. That would help me to continue what I do. And let's get back to the tutorial. Okay, so first step is creating the hexagon. So Blender is the only 3D software that I'm familiar with a little bit. So here we can go to add mesh and then cylinder. Here I'll change the vertices to 6, so this is converted to a hexagon like this. Now if I go to this view, so this is just like before. Let's make this 1 by 1 by 1. Let me enable a snapping. Okay, now this is 1 meter, so that would mean 100 units in Unreal. So this is, now if I go to the top view, if I want to make this width this way, this is now 200 units. So if I scale it, say 2.5, again I need to select all, scale, no, select all, scale, shift Z 0.5. So everything is scale, shift Z 0.5, enter. Okay, right. Now the height is 100 centimeters or 1 meter, and this length is 1 meter. This length is not 1 meter because of the shape of the hexagon. It's a bit different. Okay, now in the shading part, so here for the sides we need to have a separate color. So M sides, I'll name the default color and I'll assign something like this, and I'll select the top. For the top I need a separate slot, M top, I'll make it green. Now we can export this. Here, X forward, Z up, and yeah, that's pretty much all. And press export. Oh, one more thing, we don't want to have any smoothing, so I'll set this smoothing to face, so after importing it would look as exactly as here. Okay, now here I have imported that hexagon, and if I just drag and drop it here, it's like this. This size aligns with x-axis. For that actually I had to add this 90 import rotation when I import it, otherwise it would be like this. That would matter to the logic that we are going to write. That's why I needed to rotate it this way. And also here this voxel word I am using the scale gap 200, so that's why this is large, because this is only 100. But if I make it 200, now you see it matches this width. Okay, now I'll duplicate. This is voxel test, this map is. I'll duplicate this and I'll call it hex test. No, hex word. Okay, everything is working. Now how do we replace these voxels with hexagons? For that, here this is the voxel world blueprint. Here we have this clear grid, and then generate grid, custom events. So if I create a child class of this, create child blueprint, pp hex world. Now here, instead of this cube, I can assign hexagon. It's the sides and sides, and top and top. So basically I need to have the same materials as this cube. So instead of this also I'll assign the same hexagon. And water, top water, it's a different material. Similarly, both sides, small top, and beach also hexagon. It's all sides. Okay, all right, now we have a child class, and here if this is hex world, if I replace this voxel world here, Let's replace this voxel world with hex world blueprint. Replace selected sectors, selected actors with hex world. Okay, now you can see in place of every cube you got a hexagon, but here you see a gap. They are not perfectly fitting because we haven't accounted for these gaps. Now if I fix that, everything else should be fine. Okay, so how do we fix that? Here first, hex height and type. This is gap. The only thing that we would need to change here would be this logic where we calculate the location. So here, so let me select this and collapse to a function, calculate location, and I'll make it a pure function. So this is x index and this is y index. These two should be interchanged because usually it's xy. Right, now this returns cell location. So the modification is still happening in this voxel world. Let me compile. Everything is still working. Okay, now we don't need voxel world anymore. Here, hex world, we can override this calculates cell location function. So here, let me open the parent function and copy this. Or could I expand this? I think I could expand this too. Yeah. So we just have to modify this logic. Now the first thing is here we multiply this with the gap. Gap means actually maybe we should call this with some other name. I'll call it width. That seems more suitable. Width. But for a cube, width and height is same. But for a hexagon, it's not. To explain this, here let me draw a hexagon like this. Why is it rotated? Okay, I rotated it. So this is what I wanted to explain. Here, if I consider this as the center of the hexagon, and if I draw a line like this total length would be width. I call it W, and half of this, if I call it capital R, then this height would be, I'll call it simple r. So capital R is this, and W equals 2 times capital R, and height equals 2 times simple r. Now what you need to understand is, if we draw a circle like this, it would go like this, from through this point here, like this. So as you can see, r is a little bit shorter than capital R. So we can calculate it actually. So one of these angles, this would be 120 degrees. So here, if I draw a line, from here to here to actually any corner, it would divide this corner, this angle, to a half. That means this angle would be 60. Here also 60, and this is a right angle which is 90. So the total of angles, the sum of angles, should be 180 degrees. So this is 60, this is 90, that gives us 150 degrees, and the rest should be 30. Degrees. Okay, now since this is same as this is, because if I draw a circle, it goes through this point also. Here this is also capital R. So simple R means then simple R equals R cos 30, right? Simple geometry or trigonometry, whatever it is. So that gives us H is 2 times capital R cos 30. So that's the height of this rectangle. Okay, now let's apply this here. So we gonna need an additional variable here, because this, for the cube, it doesn't matter with height, both same. So here, well, actually if I call it height, it would be a little confusing because this is 3D. So I'll call this, instead of width, x width, and here I'll add a function y width. No, not a function, a variable. This perhaps it has to be a float, because width is a what? Oh, I need to compile this. Because even though width is integer, when we calculate the cos, it could give us some decimal value. So here, let's calculate set y width as we figured out here, 2 twice r cos 30. And actually this means twice r means width, in this case x width. So w cos 30. So w means x width and cos in degrees 30. Cos 30 multiplied by x width. That is the value of y width. Right, now then here, instead of multiplying it with, oh, it crashed, and yeah, I restarted, not much was lost. So why? Right here I deleted that problematic node. Multiply. Now here let's multiply x with x width and y with y width and use that. Now one side should be resolved. We should not have this gap if I remake the grid. See? Yeah, it's like I said. Now we don't have that this huge gap we had, bigger gap we had in vertical sides. And the next step is this part. How do we get rid of this part? So for that, what we need to do is we need to offset the cells a little bit this way. If this y coordinate is odd, 0 is here, then 0 means this side, because as I said, this is x direction and this is y direction. Oh, in that case x. If the x coordinate of this we get here. If this is odd, we need to give an offset of r, amount r. That means half of y width. So actually we don't have to worry about this part at all. We can handle it here. How? If x modulus division by 2. So when we divide x index with 2 and the remainder is 0, that means x is even. When the x is even, we don't have to do anything. But if x is odd, we have to shift the hexagon 0.5 or half the amount of y width in here downwards or in y direction. So plus here, let's do a select float. If this is 0, we don't have to add anything. If not, we have to add 0.5. Now compile, save, and generate grid. Now we see the y position is correct, but still we have this gap that we need to fill. So here the issue is, as the x gap, we have given directly this x width, which is wrong, because here, let me explain again. If I duplicate this and place it side by side, and if the center of this is here, now you see this length is r, but this length here is something else. So we can actually calculate it. This length and this length is also similar, and here we have simple r, here we have capital R, and here again we have 30 degrees. So this part, similar to this part, is R sine 30. And anyone knows sine 30 is half or 0.5. If you don't believe me, it's 0.5. Sine 30 in degrees 0.5. So that means instead of this x width, we should be using this r plus half of r. That means w is 2r. So r plus half of r means w multiplied by 0.75. So yeah, well, actually we don't have to do this every time, so I'll promote this to another variable. Let's call it x cap, and it's a simple operation, but still, why would we do it all the time, since we can just save it, do it once and keep it. This is set x cap. Right, I think that's all. What happened? Oh, I was inside. Okay, so yeah, now you see everything fits perfectly. Yeah. Oh, sorry. I should have used X width here, not Y width. That's why I have this some odd placement. Yeah, correct. So about that. Yeah, now everything is perfect. So here I increased this to 0.1 so that we can see the gap a bit more clearly. Just decrease the size of the scale of this hexagon, but if you leave it 1, it would fit perfectly, but I don't want to do that, so maybe we can reduce this 0.3. Generate. Yeah, now you see how much thinner gap. So yeah, that's all I wanted to do for today. Now that we have implemented the hexagons just like before, all other parameters are working without any issue. Cool. So thanks for watching. As always, updated project files will be available for the download in Patreon page. Link would be in the description below. And see you in another episode. Feel free to make suggestions on what else I should be doing in this series. So far I don't have any other plans, any other solid plan. Maybe if I come out with some other ideas like placing foliages, I would do that. But feel free to let me know. And thanks again. See you in the next episode. Goodbye.